An ion is an atom that's going to gain or lose electrons in order to have a full valence shell. If you have something like magnesium, magnesium without the charge here has 2 valence electrons. Or if we look at something like bromine, bromine has 7 valence electrons. Each of these atoms are both wanting to gain or lose electrons in order to get that full valence shell. They're always going to take the path of least resistance, is what I like to call it, where we have 2 electrons here. 8 is our magic number for everything except for hydrogen and helium. It's easier to lose these 2 electrons than it is to gain 6 more. So magnesium is going to be a case where you're going to lose electrons. Bromine has your 7 valence electrons around the outside. Having those 7 valence electrons around the outside, it's easier to find one to fill in that spot than it is to get rid of those 7. If you have a cation or an anion, those are the 2 types of ions. Cations have positive charges, anions have negative charges. Cations are going to lose electrons, anions are going to gain electrons. So magnesium that has a +2 charge here is an example of one that's going to lose those 2 electrons. Bromine has a negative charge. That's an anion. That one's going to be an example that's going to find 1 electron and put it on its valence shell. With your gaining and losing electrons, you have your oxidation numbers. The oxidation number is just like +2 or -3, +1 or -1. It tells you how many electrons are gained or lost. So if this has a +2 charge, you're losing 2 electrons. If you have phosphorus, it has 5 valence electrons. It's going to gain 3 more. Silver has this 1 electron that it's going to lose, and then we already talked about the fact that bromine finds 1. So if you have a plus or a minus and there's no number there, it's implied that it's a 1. We typically don't write that number 1 though. It's like many other cases in chemistry that we're not going to write the number 1 at all. With your protons, neutrons, and electrons, so far we've said that your protons and your electrons need to be the same to make it electrically neutral. However, with magnesium with a +2 charge, it's no longer electrically neutral because in this case we're losing 2 electrons. So what you need to do is find the magnesium on the periodic table. Magnesium is number 12. So with magnesium being number 12, that means that we have 12 protons. Initially, we had 12 electrons. However, this is telling us that we lost 2. So 12 minus 2 is 10 electrons total. Same thing with phosphorus. I'm going to find phosphorus on the periodic table. Phosphorus is number 15. With phosphorus being number 15, it should have 15 electrons, just like my 15 protons. However, I have a -3 charge. Because I have a -3 charge, that means that I gained 3 electrons. So 15 plus 3 is going to give me 18 electrons total on phosphorus with a -3 charge. If you have silver with a +1 charge, I'm going to find silver on the periodic table, which is right here. It's number 47. I should have 47 protons and 47 electrons. However, with this +1 charge, that means that I lost 1 electron. When I lose 1 electron, I no longer have 47. Now I have 46 electrons. Bromine, find it on the periodic table. It's number 35. So I should have 35 protons, and I should have 35 electrons. However, I'm finding 1 electron and I'm putting it on its valence shell to give it 36. Now if you look at this, magnesium has 12 positive charges, 10 negative charges. The difference between those two is +2. Here I have 15 positive charges, 18 negative charges. The difference between those two is -3. So with your positive protons and your negative electrons, the difference between them is where that oxidation number comes from. Just like your valence electrons on the periodic table, your oxidation number is also something that you can predict. If you're in group 1, those have a +1 charge. Excuse me. Group 2 all have a +2 charge because these all have 2 valence electrons. Group 13 is +3. 14 is plus or minus 4. If you're above the stair-step line, you're a nonmetal, you're going to have a negative charge. Below the stair-step line is typically positive, or they're all positive, sorry. They're typically +4. We'll clarify that more later. Group 15 is -3. Group 16 is -2. And group number 17 all have a -1 oxidation number. So if you needed to find the oxidation number for iodine, iodine is -1. Or if you needed to find the oxidation number of beryllium, beryllium is +2. So your oxidation numbers for your representative elements for these and for these are all predictable. Notice I left out the noble gases. Noble gases have a full valence shell, so they don't gain or lose electrons. This middle portion here we'll talk about later, but that middle portion, your transition metals, they're all going to lose electrons. They all have positive charges, but they're going to lose different amounts of electrons. So we'll clarify how many they lose later on.